Hi guys, this is 6.4, recognizing end behavior of graphs of polynomials. So end behavior, remember the end behavior format, we have already covered this before. We always write it the same way. We write as x approaches positive infinity, which represents on the right side. And then we say, where does y point? On the right side of the graph. We can say positive infinity, negative infinity. It means it's going up or down on the right side. Then on the bottom, we write as x approaches negative infinity. And that it represents on the left side because x negative infinity is the left side of the graph. So as x approaches negative infinity, as we look on the left side of the graph, where is y going? Is y going up or is y going down? Which again, we would write as positive infinity or negative infinity. So when we're looking at these graphs over here, notice that for quadratics, it is both ends facing the same direction. So both ends go up, or if it's downward facing, then both ends go down. And so the ends are facing the same way. And notice again that this is a quadratic function, which has a power of 2, which is an even power. Then we have something like x cubed, or even like a linear, right? Where the power is odd. It's an odd power. And notice that on this one of the ends, like this one on the right one, this one is going up, but the other end is going down. And on this other one, even though the left side is going up, the right side is going down. So the takeaway of this is that when you have an even degree function, when the power is something that is an even number, 2, 4, 6, 8, any even degree will be facing the same way. Both ends are facing the same way. So both are up, like the left side up, the right side also up. The middle could be different because quadratic, yes, it's a power 2, so the middle is a nice parabola. But when the power is something higher than 2, which we're going to see in this unit, the middle could be a little bit like wonky and weird and squiggly, okay? But the ends, okay, we're talking about the ends in this lesson. The ends are going to be facing the same way, either both up or they're both down. But they're facing the same way. Now, how do we know if it's up or down? Well, up means that it is a positive a value, which means that the coefficient in front is positive. Negative is a negative a value, and that's where the ends would be facing down. Now, the most simple odd is a linear, right? We've seen linears before. And so with odd, with an odd degree, that means that both the ends are facing opposite ways. Let me write that way because it's not both. It's the ends are facing opposite ways. So that means one's up and the other one's down, right? If this one is up, then this one is down. So they're facing different directions or different ways. So one thing that can happen is the right side is up, but that means the left side is down. Or if the right side is down, then the left side would be up. Okay? And again, with this one, it depends on if the front number is positive or negative. So if it's a positive front number, which you could think like positive slope, right? Like it goes up. It's increasing overall from left to right. Or if the front number is negative, if the coefficient is negative, then overall it goes down from left to right. So let's go ahead and take a look at the leading term. Notice that f of x, just to make this very clear, f of x was x squared. G of x was x cubed. H of x is negative x squared. And m of x is the negative x cubed. And notice, the a value is the number in front, okay? The a value is the coefficient. The a value is the coefficient. Let's write that down. Coefficient. The a value is the coefficient. If the coefficient is a positive number, and then here on H and M, the coefficient is a negative number. -1 is a negative, okay? So the coefficient on those two are negative. The value of n, notice on n is the power. N is the degree. Let's make sure we write that down, okay? So a is the coefficient, the n is the degree. And if the degree, notice f of x, the degree, that's even power. For g of x, the degree, that's odd power. H of x is an even power, and m of x is an odd power. What ends up happening, again, is if they are even, that one's the easiest one because they're both facing the same way. It would make sense that positive, then both ends are facing up, which means that you would have both ends going up to positive infinity. If it's even, but the coefficient is negative, then that means that both ends would be facing down, which means that on both sides, left and right, we would be going to negative infinity. For g of x and m of x, this is an odd power. This is the one where one side is up and the other side is down. So when we have a positive coefficient, then overall the ends are going up from left to right. So on the right side, it goes up, but on the left side, it goes down. So they're not facing the same way like the even ones. If you have a negative coefficient, then that means that overall it's going down from left to right. So the right side goes down and the left side goes up. So this is the end behavior for all four possibilities of what could happen. Even, odd, and then positive, negative, positive, negative. So that is the end behavior, okay? Now you determine the end behavior. These were very simple because they were all monomials. They were the simplest version of that type of polynomial. But how you determine the degree and the coefficient is by looking at what is called the leading term. So if you have more than one term, you're going to look at the term with the highest power. That term with the highest power is how you obtain the degree, which we already covered in 6.1, and that is the term that you need then the coefficient for so that you know whether it's positive or negative, okay? So there's really just 4 possibilities, okay? I have an even function and it's positive, which means that both ends are facing the same way. As x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches negative infinity. Or excuse me, positive infinity. Because it is even and positive. So both ends face the same direction. If it's positive and odd, then that means that it's different directions overall going up from left to right. So the right side end is going up, but the left side end is going down. If it's even but negative, then both ends are going down. Y on the right side goes to negative infinity, and y goes to negative infinity on the left side as well. Notice on this table, this is the right side, and this is the left side. And then if it's negative and odd, then that means that overall I'm going down from left to right. So on the right side, it goes down to negative infinity, and on the left side, it goes up to positive infinity. Okay, I explained those four options because it's really just four possibilities as far as end behavior goes, right? Both ends up, positive even, both ends down, negative even, or different directions, positive odd, right side up, left side down, or negative odd, right side down, left side up. So now that we've gone over the four possibilities in three different ways, let's go ahead and do some examples. So we're going to determine the end behavior of the graph of the polynomial function below. We need to simplify it. We can't do anything unless we simplify the polynomial. So we're going to go ahead and distribute the negative. So we have negative 3x squared plus x minus 3x plus 2x cubed. I can combine these two in the middle. 1x minus 3x would end up being negative 2x. So let's write it in standard form. So that way the first one is the one with the highest degree, and therefore it is our leading term. Okay, but the leading term doesn't have to be in the front. Actually, you know what? Let me not write it in standard form. Let's say I write it as negative 2x squared minus 2x plus 2x cubed. Now remember, you determine the leading term. You have to use the leading term to determine the end behavior. You cannot determine the end behavior unless you have your leading term or without looking at the leading term. So the leading term is not whichever one. It's kind of misleading, that terminology, because the leading term is not the first one. It's the one with the highest power. So it is the leading term if you have it in standard form. Okay, if it's in standard form, which remember, standard form means that you're writing it from highest power to lowest power, then f of x would be 2x cubed minus 3x squared minus 2x. And then the first one is the leading term. But if you don't have it in standard form, you don't just want to look at the first one. That's not the leading term just because it's in the front. The leading term is still the 2x cubed because the leading term is defined as the one with the highest power, with the highest exponent. So my leading term, remember, you're going to look at the power. The degree is odd. And you're going to take a look at the coefficient, the number in front, to determine positive or negative. Do not mix them up. It's very easy to mix it up. So you're going to need to study. This is not a difficult concept. It's just something that, has required a little bit of studying and, kind of thinking about, okay, the even one kind of makes sense, but then you might have to develop some kind of to remember the positive or negative. I think okay, the simplest odd is linear, right? If a linear has a positive slope, it's going up overall from left to right. If a linear has a negative slope, then it's going down overall from left to right. So that's how I remember it. Maybe you can use that or come up with another thing. But this is not difficult, right? We just have to remember a couple things. And one of those things is that we use the degree to determine even or odd. And we use the leading coefficient, which is the coefficient in front of that term that you just found the degree from, to determine if it's positive or negative. Okay? Do not mix them up. Don't look here and say, oh, that's even. You look at the power. The power, the degree, tells us even or odd, and then the coefficient in front tells us positive or negative. So since this is odd and positive, this is our end behavior right here. As x approaches positive infinity, y approaches positive infinity. And as x approaches negative infinity, y approaches negative infinity. And you can replace y with f of x to get a little bit more fancy, since they use function notation here, but it's the same thing. Okay? So since this is odd and positive, again, if I were to look at the ends on a graph, right, I would see that the right side end is pointing up, and that if I look on the left side of the graph, the left end is going down. Now, the middle here is different, right? If I'm looking at an actual graph, the middle might be some squiggly in between because I have a higher power, right? This is not a quadratic, so the middle is going to be weird and squiggly. It's not a linear, right? So it's not going to be a straight line. That would be power 1. It's a cubic, which actually looks something like this. We're going to be graphing these, okay? That's like not this lesson, okay? We're just talking about the ends. But the ends are very important because knowing how the ends look is a part of making your graph, okay? So that's the end behavior. That's our first example. Let's go ahead and do another one. So we're going to determine the end behavior of the graph, and justify is just like writing the work for it, okay? So looking at this, our leading term would be negative x to the power 4 because that's the one that has the highest power. I don't have to write it in standard form. They didn't ask me to do that, so that's okay. So I know that that's my leading term. Now I take a look at the power to determine even or odd. 4 is even. I look at the coefficient, the number in front, to determine positive or negative. Negative 1 is negative. So this is even and negative. Even and negative means that both ends are facing the same way, and they're both facing down. Even, both the same way, negative, down. So end behavior. Well, that's the annoying thing about end behavior is like writing out the front part. So as x approaches positive infinity, y goes down to negative infinity. And as x approaches negative infinity, then y also approaches negative infinity. So how you read this would be right side down. On the right of the graph, if you look to the right, it'll be down. And then on the left side of the graph, if you look to the left side, that will also be pointing down. Okay? But the end behavior is described like this. So it's just like a fancy way in math to write that, to say right side is down, left side is down.